Look up at the night sky, and there it is, that pale, pockmarked sphere, hanging in the darkness like it's always been there. You've seen it a million times, barely give it a second thought anymore. But the moon isn't just some cosmic decoration. It's the reason you exist at all. Without it, Earth would be a spinning nightmare of chaos, and life as we know it would never have crawled out of the primordial soup. So let's talk about why that dusty rock 238,000 miles away is literally holding your world together. Number 1. The moon stabilizes Earth's tilt. Earth spins on an axis tilted about 23.5 degrees, and that tilt gives us our seasons: spring, summer, fall, winter. The rhythms that govern when crops grow, when animals migrate, when you decide whether to wear a jacket. Seems stable, right? Wrong. Without the moon's gravitational pull acting as a cosmic anchor, Earth's tilt would wobble like a drunk on a tightrope. Mars gives us a perfect example of what happens without a decent-sized moon. Its tilt varies wildly over millions of years, swinging from 13 degrees to 40 degrees. Translation: one epoch you've got polar ice caps, the next you've got ice at the equator and deserts at the pole. Climate chaos that makes our current problems look like a minor thermostat adjustment. The moon keeps Earth's axial tilt stable within just a few degrees over millions of years, creating the predictable climate patterns that allowed complex life to evolve. Without it, seasons would be unpredictable disasters, temperature swings would be extreme, and evolution would constantly be hitting the reset button. Number 2. Tides, the ocean's heartbeat. The moon creates tides, and you probably think that just means the beach gets bigger and smaller twice a day. You're missing the bigger picture. Tidal forces from the moon pull on Earth's oceans, creating bulges of water that move around the planet as it rotates. These aren't gentle ripples. We're talking about trillions of gallons of water sloshing back and forth across the globe every single day. This movement does something critical. It stirs the oceans. Deep, nutrient-rich water gets pulled up toward the surface. Warm surface water gets dragged into the depths. This circulation drives ocean currents, distributes heat around the planet, and creates the environmental conditions that made tidal pools, those shallow mixing zones where the first complex organisms likely evolved. Some scientists think life itself started in these tidal zones, where the rhythmic ebb and flow created perfect conditions for organic molecules to concentrate and combine. No moon means no significant tides, which means stagnant oceans, which means Earth's water becomes a lifeless puddle. The moon literally taught the oceans how to breathe. Number 3. Slowing down time itself. The moon is slowly stealing Earth's rotational energy, and it's been doing it since the day it formed. Every year, Earth's rotation slows down by about 1.4 milliseconds. Doesn't sound like much until you run the numbers backward. 4 billion years ago, when the moon first appeared, a day on Earth lasted only about 6 hours. The moon was also way closer, maybe 15,000 miles away, instead of 238,000. The tides back then weren't gentle ocean swells, but catastrophic walls of water that would have made modern tsunamis look like bathtub splashes. Over billions of years, the moon has been gradually putting the brakes on Earth's spin, while simultaneously drifting away at about 1.5 inches per year. This slowdown gave life time to adapt. A 6-hour day means vicious temperature swings, brutal winds, and no stable climate. As Earth's rotation slowed, days lengthened, conditions mellowed, and life got the stable environment it needed to diversify. The moon didn't just give us time. It literally created time as we experience it, stretching out our days from a frantic spin into something livable. Number 4. The moon's violent birth. The moon exists because Earth got absolutely destroyed about 4.5 billion years ago. A Mars-sized planet called Theia slammed into early Earth at roughly 9,000 miles per hour. The impact vaporized Theia, liquefied Earth's surface, and ejected a massive cloud of molten debris into orbit. This superheated rubble eventually clumped together to form the moon. This wasn't some gentle cosmic assembly. We're talking about a collision so violent it literally melted an entire planet and nearly destroyed ours. The energy released was beyond comprehension, enough to create a glowing cloud of vaporized rock surrounding Earth for thousands of years. But that catastrophic violence gave us something precious. The debris that became the moon carried away a huge chunk of Earth's angular momentum, the reason our planet doesn't spin so fast it tears itself apart. The impact also tilted Earth's axis, setting up the axial stability the moon would later preserve. So yeah, The moon is a monument to one of the most destructive events in our planet's history. And that destruction is exactly why we're here to talk about it. Number 5. The moon as Earth's cosmic shield. The moon doesn't just sit there looking pretty. It actively intercepts asteroids and comets that would otherwise hit Earth. Look at the lunar surface through a telescope, and you'll see it's absolutely cratered, pounded by billions of years of cosmic impacts. Those craters aren't just scars. They're tombstones for rocks that never made it to Earth. The moon's gravity, while weaker than Earth's, still deflects incoming objects, altering their trajectories just enough to send them careening off into space or into the moon itself. Scientists estimate that the moon has absorbed countless impacts over billions of years, each one a potential extinction event that never happened. Sure, Earth still gets hit. The dinosaurs can confirm that. But without the moon running interference, the bombardment rate would be significantly higher. You'd be looking at apocalyptic impacts not every few 100 million years, but potentially every few million years. Complex life needs time to recover, evolve, and diversify. The moon buys us that time by taking the hits. Number 6. The cultural and psychological moon. Every human culture that ever existed has looked up at the moon and built mythology around it. Calendars, festivals, agricultural cycles, navigation, timekeeping. The moon gave ancient humans their first real clock, a predictable cycle that repeated every 29.5 days. Farmers planted crops by it. Sailors navigated by it. Religions structured holy days around it. The moon became embedded in human consciousness in ways that shaped civilization itself. But it's more than cultural. Recent studies suggest the moon's light affects animal behavior, hormone cycles, and even human sleep patterns. Some species time their reproductive cycles to lunar phases. Coral reefs spawn in synchronization with the full moon. Predators hunt more successfully during specific lunar phases. The moon's gravitational and light cycles have been ticking in the background of Earth's biology for so long that countless species, including possibly humans, have evolved responses to its presence. Imagine a world without that pale light at night, without that predictable cycle hanging in the sky. Navigation becomes harder. Natural rhythms get disrupted. The psychological impact of a moonless night sky would be profound in ways we can barely measure. Number 7. The moon is leaving us. The moon is drifting away at 1.5 inches per year. And that rate isn't slowing down. Do the math far enough into the future, and you get a terrifying scenario. In about 600 million years, the moon will be too far away to create total solar eclipses, those perfect alignments where the moon exactly covers the sun. A cosmic coincidence we currently enjoy will be gone. But the real problem comes later. In a few billion years, the moon will be so distant, its gravitational influence will weaken dramatically. Earth's axial tilt will start to wobble. Tides will diminish. The climate stability we depend on will unravel. Earth won't become instantly uninhabitable, but the slow motion collapse of the moon's stabilizing effects will make the planet increasingly hostile to complex life. By the time the moon reaches its maximum distance, assuming Earth still exists and hasn't been swallowed by an expanding sun, our planet will be a very different place. The moon that gave us life will have abandoned us, drifting silently into the darkness, while Earth spins into chaos. We're living in the golden age of the Earth-Moon system, and the clock is ticking. Number 8. What we lose without the moon. Run the counterfactual. Imagine Earth formed without the Theia impact, without a moon. You get a planet spinning wildly fast, maybe a 10-hour day, creating winds that would shred any atmosphere thicker than a whisper. The axial tilt would wobble chaotically over geological timescales, creating climate swings so extreme that ice ages and hothouse periods would alternate unpredictably. No significant tides means stagnant oceans with minimal circulation, no nutrient mixing, no tidal pools for life to get started. No long-term climate stability means evolution can't build complexity because the environment keeps resetting. You might get single-celled organisms, bacterial mats, maybe some extremophiles clinging to existence near hydrothermal vents. But forests, animals, intelligence, civilization, forget it. The moon isn't just important. It's the difference between Earth as a living world and Earth as a barren rock with a thin smear of bacteria. Every breath you take, every step you walk, every thought you think exists because a Mars-sized planet crashed into Earth 4.5 billion years ago and left behind a companion that's been holding things together ever since. Number 9. Our only natural satellite. Earth has one moon. Just one. Mars has 2 tiny captured asteroids. Jupiter has 95 moons, but they're mostly ice chunks and rocks. Saturn has 146, including Titan with its methane lakes, but none of them stabilize their host planet the way our moon stabilizes Earth. Our moon is disproportionately large compared to Earth, about 1/4 the diameter and 1/80th the mass. No other rocky planet in our solar system has a moon that's proportionally that big. This size relationship is what gives the moon enough gravitational oomph to lock down Earth's tilt, create substantial tides, and slow our rotation to something livable. It's a Goldilocks scenario that required a planet-killing impact to create. Too small a moon, and you don't get the stabilizing effects. Too big, and the gravitational interactions would be destructive. Our moon is exactly the right size, formed in exactly the right way, orbiting at exactly the right distance to make Earth habitable. Call it luck, call it cosmic coincidence, but the fact remains, we won the lottery. And that pale sphere hanging in the night sky is the winning ticket. Number 10. The moon and the future of humanity. The moon isn't just our past, it's potentially our future. Water ice exists in permanently shadowed craters at the lunar poles. Resources like helium-3, potentially useful for future fusion reactors, sit in lunar soil. The moon could serve as a staging ground for missions deeper into the solar system, a low-gravity construction site for spacecraft too massive to launch from Earth. But the deeper significance is this. The moon is the only other world humans have ever walked on. 12 people left footprints in lunar dust between 1969 and 1972, and those prints are still there, preserved in airless silence. The moon represents what we could be, a species that doesn't stay confined to one world. Looking up at it reminds us that the universe is reachable, that the darkness beyond our atmosphere isn't an impenetrable barrier, but a frontier. The moon made us possible by stabilizing Earth. Now it offers us a way forward, a stepping stone to survival beyond our home planet. When Earth eventually becomes uninhabitable, whether from our own mistakes or the sun's inevitable expansion, the moon might be where we learn the skills to escape. Number 11. The silent partner. You spent your whole life under the moon's influence and probably never noticed. It's always been there, waxing and waning, pulling the tides, steadying the planet beneath your feet. You don't think about it because it just works, silently doing its job across hundreds of millions of miles of empty space. But cosmic arrangements aren't guaranteed. Most planets don't have moons like ours. Most solar systems don't have stable, habitable zones. The moon is a gift from a violent past. A stabilizing force born from destruction, a companion that's been keeping Earth livable for 4 billion years. And it's leaving, slowly, inexorably, drifting away at the speed your fingernails grow. One day, billions of years from now, it'll be too far away to hold things together, and Earth will wobble into chaos. But right now, tonight, it's still there, still anchoring your world, still making everything possible. Look up sometime and appreciate the pale guardian that's been watching over Earth since before life existed. It's more important than you ever realized. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.